Hello students, so today we will be seeing motion under gravity. Motion under gravity. Motion under gravity. So let's understand this. So all of us should understand what is motion under gravity. So suppose there is an object, right, which is moving only due to the influence of gravity. Moving means the motion of the body is affected only due to gravity. So only due to gravity means gravity, earth is applying a force, right? So there will be acceleration due to earth, right, due to gravitational force, and that acceleration is called g, right, acceleration due to gravity. And if you consider downward direction as negative, then you can write this as minus. So plus minus will depend on the sign convention, right? The value of g is 9.8 meter per second square. Sometime in the question they will give the value of g as 10, then only we should take it as 10, otherwise it will not come, answer will not come correct. So when they give g, take g as 10, then only we should take it as 10, otherwise we should use 9.8. okay, because there's a lot of difference happens in calculation. Okay, so unless they have mentioned, we should not take. Clear? Okay, now let us understand what are the things that we are going to do. So this is a uniformly accelerated motion. This is uniformly accelerated motion. Uniformly accelerated motion. Okay, so all the equations of uniformly accelerated motion we can apply, but now we are going to see some case studies here so we can remember those formulas, right? So let's take the first case, case 1. Now let us say you are going to let us say throw a body from ground. From the ground you are going to project a body. Let's say this is a body and you are projecting it upward. Okay, so motion under gravity, only gravity, no friction or no other kind of forces are there. No friction or drag forces. So motion under gravity, it is also known as one-dimensional projectile motion. So here we are going to study 1D projectile motion. One dimensional, and say straight line motion. Okay, so you are throwing it like this. So first of all it will go and then the body will stop some point, isn't it? Let's say it will stop here. So again after that it will return back. Again it will return back to the ground. So the question is, what will be the maximum height it will have? And you are projecting with a speed u, right? So what is the height, maximum height? What is the time taken to go up? That is called time of ascent. What is td? Time of descent. And what is the total time, which is time of ascent plus time of descent? This t is the time of flight. Okay, so let's study this. So as we are throwing it upward, the velocity is upward. So here acceleration is downward. So you can take acceleration minus c, right? Upward as direction positive, downward negative. Upward direction positive, downward direction negative. Okay, so when it reaches this point, first of all, the velocity will become 0 here. So we can use v equal to u plus at, v is equal to u plus at. This equation we can use. So then final velocity becomes 0, initial velocity is u, acceleration is minus c, time is time of ascent. So time of ascent you will get as u by g. Okay, time of ascent formula u by g. This we should note. Time of ascent. Similarly, time of descent will also come. You can study from top to bottom, starting with u, and then it is going to this, right? So you know, while it will be coming back, it will original speed it will gain at the ground, right? So final velocity here you can say it will be u only when it will be coming back to this, right? It will have same speed as u. Okay, so time of ascent and time of descent both are going to be equal as u by g. So the total time of flight will be 2u by g. Okay, total time of flight will be 2u by g. Okay, now what is the maximum height h? Now we can study maximum height. So we can use v square equal to u square plus 2ax. Final velocity 0, initial velocity u square, axis is minus g and x is h. So from here you will get h is equal to u square by 2g. So this formula you need to know. This is the maximum height. So we got the formula for maximum height and total time of ascent, time of descent. Okay. So in this model of question, they can also ask, suppose if you throw a body projected with a velocity u like this, it will go up, and then I am separately showing another line like this. Although this is the same line, but it will be coming down. Now if you see a particular height from the ground will be crossing at two levels. This is the ground. Okay, so suppose this is a particular height h. This height will be crossed at two times, one while going up, another while coming down. Okay, so let's say this time is time t equal to t1, and while coming through this same point t equal to t2. Okay, t equal to t2. So t equal to t1, t equal to t2 are the time instant. Okay, it is the time instant when the particle will be at a given height. So to calculate this, you can use this y is equal to ut plus half at square. Okay, y equal to ut plus half at square. This equation you can use when you put y is equal to h. Okay, u is initial velocity, u, t minus half g t square. From here you try to solve t, right? So what do you get? Make a quadratic equation, gt square minus 2ut plus 2h is equal to 0. This quadratic equation, when you are going to solve it, will give two roots, t1 t2. So sum of t1 plus t2, if you see time, sum of the roots is minus b by a, so you will get 2u by g. You see t1 plus t2 is actually the total time of flight that we can note, right? Sum of the time is time of flight. Another thing that we can note is the t1 minus t2 also we can calculate, right? So you can solve t1 minus t2, difference of the roots, because t1 into t2, if you can solve, t1 into t2 is c by a, so it will be 2h by g, right? Isn't it? 2h by g. And you can also solve t2 minus t1, right? Difference of the roots. So how much will be the difference of root if you try to solve t2 minus t1? t2 minus t1 from here can be calculated, right? As you can solve, because t1 plus t2 we know, t1 into t2 we know. We can try to find out this square as t1 plus t2 whole square minus 4 t1 t2, correct? Or there is another way. From here t2 minus t1 can be calculated, but there is another way to solve it. If you can calculate the velocity here, let's say at this point, right, some velocity will be there. So what is this velocity? If you calculate, this velocity will be root under u square minus 2gh, right? Now from here to here, this difference of the interval means what? T2 minus T1 means how much time this, right? So that is like, and you can shift the ground upward. If you shift the ground upward, let's say this is like, then V will become initial velocity. So T2 minus T1 can become like the time of flight, which was 2u by g. Here it will become 2v by g, right? It will become 2v by g, where v is given as root under u square minus 2gh. Okay, that's how we can solve it. Clear? So we can of course solve from here, or we can solve from here. We have two approaches to solve this T2 minus T1. One from this equation, another from this equation. Both the equations will work out. Okay. Right, then let us go next. This is one case. Now let's go next, case number 2. Case number 2. In this case, you can drop a body from some height. Suppose this is a building of height h. Okay, this is ground. So here you are dropping a body. You are going to drop a object. So as you are dropping, it is going down. And because you have dropped it, so initially speed is 0. Okay, acceleration, now you take downward direction as positive, because downward motion is only happening, so motion is only downward. Take it as positive. Okay, so acceleration you can take as plus c, but during a calculation you should keep only one sign of acceleration. You cannot use both the sign, right? So here if you are taking g positive downward means plus g, right? So you should keep it as it is throughout the calculation. Downward direction is positive, upward direction is negative. Okay, so then what time it will take to reach, what velocity it will take to hit the ground, that we can calculate. What is the velocity and how much time it takes to reach. So directly we can calculate v square equal to u square plus 2x. So v square is equal to u square plus 2x. So initial velocity 0, 2g, this is h, v square. So v becomes root under 2gh. This formula we will use for velocity, final velocity. Time of flight we can use s is ut plus half a t square, right? So this is h, u is 0, half g t square. So from here total time of flight, it is a descent only, root under 2h by g, right? This is what. So two result is here in this case too. Then you may throw it also downward. Let us say you throw it downward, not just drop it, you throw it. So that will be case 3. In case 3, you are going to project it downward. From the building of height h, you are going to project this ball with a speed u. So again it will be having some speed when it comes at the ground, some speed v. So v will be given as root under u square plus 2gh. And time of flight, total time taken. So here time taken will be given as v minus u by g. Okay, so you can calculate these equations using the same formulas. Okay, these two important results are there. Then from the height you can throw it upward also. Let's take another case, case 3. This was case 3. Case 4. Case 4. Okay, you are going to project this body in the upward direction from a height of h. From a building of height h, you project it with you. So what will happen? It will stop and then it will come back. So you see, this is a combination of previous few cases, right? it is going up and this is going again down. So here the question is, what will be the speed when the ball will be reaching the ground? Okay, what will be speed? So speed formula will be same as previous case, u square plus 2gh. Okay, then what is the time taken? Total time. Here total time taken will be v plus u by g. The best way to remember is by this approach, v plus u by g. Okay, so in this manner we can remember all these results, and then we can solve questions, right? Motion under gravity, these are the important equations which you can use to solve problems. Okay, then coming to next there can be relative motion. Let us see relative motion. Relative motion in general, first we'll discuss whether it is 1D, 2D, 3D. So relative motion means the observer will be sitting on one of the body, or one of the body is the observer. Let us say that this is body A and this is body B. Okay, let's say its velocity is in this direction VA, and let's say its velocity is in this direction VB. Okay, in general, this is of course vector. We'll discuss vectors in more detail, but here you should understand that this is vector VA VB. So if I want to represent velocity of A with respect to B, so with respect to B means observer will sit on B. So let us see how we are studying A, right? A, this is A and this is B, but the observer is going to sit, observer will be sitting on B. Okay, this is the observer now, observer. So what will happen, this velocity of A, which is like this VA, will be like this only. Okay, but the B will add its negative velocity to A. So its negative velocity of B is in this direction, right? This is the velocity vector of B. Negative of that will go in this direction. This is minus velocity of B. Now the resultant of these two, using parallelogram law, we can calculate. Okay, resultant of this we can calculate like this. So this will be the resultant velocity of A with respect to B. Okay, velocity of A respect to B. So this is the definition. Velocity of A with respect to B is velocity of A minus velocity of B. Correct? This is the definition, and it is valid for any kind of vectors, 1D, 2D, 3D, right? If you take particularly one dimension, then we don't have to write it as a vector symbol. It will be just written with plus minus sign, right? Let us take that one dimension case. One dimension, relative motion in one dimension. So if you consider a body which is moving with, let's say, VA, and let's say this body is moving in the same direction VB. So both are plus, both velocities are plus. So if you write VAB, that means VA minus VB. This is what it is. It may come plus, it may come minus. Similarly, VBA will be VB minus VA. Both are in same direction, so positive we have to keep. Okay, now if they are in opposite direction, let us say this is the A, it is going in this direction, and this B, it is going in this direction. This I am writing as a speed. Okay, VA VB I am writing as a speed. Now if it is going like that, we have to put minus, because this is plus, this is minus. So VAB will be VA minus VB. Now VB is minus of VB, right? It will, you see, it will become plus. Similarly, if you are writing VBA, so VB minus VA, but VB is minus itself because direction is opposite. minus VA. So this will become minus of VB plus VA. Here VB, VA, that is just the speed. When you give plus minus, it becomes velocity, directions. Okay, so VA, VB is just the magnitude you can take. Okay. So when you do subtract, you have to take care of the signs. And when you take care of the sign, then that means you are considering it as a vector. And then calculations you can do. One example we will discuss. Okay, relative motion. So if you suppose that there is a building of height h and you have thrown this with a velocity of u1, at the same time from ground you are throwing another ball, right, with a velocity u2. This is an example. Now what will happen where they are going to meet, or at what height they meet? Certainly they are going to meet somewhere, right? This is the first ball, this is the second ball. So somewhere they will meet. This is first, this is second. Somewhere they will collide. So this is the first one, second one. Upper one is first, this is the lower one. So what height they will collide, what time they are collide? We are projecting both of them simultaneously at the same time. What time they are going to collide? So if you study relative motion, so acceleration of 1 is also minus c, acceleration of 2 is also minus c. Both are under gravity. So there is no relative motion acceleration of 1 with respect to 2. If you see, it is 0, right? Acceleration of 1 minus acceleration of 2. That will become 0. So that means if you study 1 with respect to 2, there is no relative acceleration. It will be like a uniform motion. So with respect to 2, if you see the first body, the initial velocity of 1 with respect to 2 is, now you are doing opposite. So it will become added, right? This is the magnitude, of course, even U2 magnitude. So this will get added because the bodies are moving in opposite direction, and this velocity will remain constant. Okay, because there is no acceleration, and relative separation between them, or displacement between them, x, let's say 1, 2, that is going to be h. So the time when they will meet is displacement by velocity. Displacement is h by u1 plus u2. So once you use this formula, you can calculate the time when they are going to meet. Once you know the time, then you can calculate, let's say you want to calculate at what height they are meeting. So this is the height and this is the time when they meet, h by u1 plus u2. So you can calculate this height. H is equal to, if you take for the bottom one, ut minus half g t square. Now you are studying only the upper one. So this ut t is h by u1 plus u2 minus half g, this h by u1 plus u2 whole square. So this is the height from the bottom where they are going to meet, right? This is the height from bottom where they will meet. If you have to find height from top, let's say that height is y. This height is y. So this y will be, initial for u is 0 only, half g t square. Half g t means h by u1 plus u2 whole square. Now you will say, why are we writing plus g here and not minus g? Why? Because for this the motion is downward for the upper one, right? Downward means velocity downward, acceleration also downward, but same direction, so we are taking positive. Otherwise you may write this as minus y, displacement is downward, and minus g, minus will get cancelled. Okay, so this is one example which is generally asked in the problems. So I hope you have understood motion under gravity and relative motion in one dimension. Two dimension also idea I have given, but that we'll discuss afterward in more detail. Okay, thank you for your attention.